Okay, so we have this question, next question here. A high-speed train accelerates from rest along a straight horizontal track. The final speed of the train is 76 meter per second. Show that the useful work done to accelerate the train is about 2 gigajoules. Now the mass of the train is 7.2 times 10 raised to power 5 kg. So you have to solve this question with a strategy. What is that strategy? The first step is to write the values you have. You have final velocity, which is 76 meter per second, and you have mass, right, which is 7.2 times 10 raised to power 5 kg. Sorry, kg. Now the second step, think of the formula which will help you get work done. Okay, formula. So work done, what is work done? Work done is like another form energy. Okay. And what is the energy formula? Because why I say an energy? Because if you notice the units, it's like work done has a unit joules and energy also has a unit joules. Okay. So they're basically they're basically the same thing. Now to get energy from the formula sheet, I can see that I can use the formula of kinetic energy, right? Kinetic energy is, wait, E is equals to K 1 by 2 mv square. Okay, and this will also give me answer in joules, kinetic energy. Okay, so the next part, so the next step is to just input the values. So if you input the values, it is Ek is equals to 1 by 2, m is 7.2 times 10 raised to power 5, and then you have speed, which is 76. And if you write your answer and in rounded off form, it will be somewhat around 2.1 times 10 raised to power 9, right? It was something like 2.08 times 10 raised to power 9. Yeah. And you should know that giga is basically 10 raised to power 9. Okay, giga is 10 raised to power 9. So if you replace this 10 raised to power 9 with the word g, it will be something like Ek is equals to 2.1 g joules. Make sure to write your units as well. Don't forget your units. You will lose marks if you forget your units. So I have hence proved that your useful work done is to accelerate the train is about 2 gigajoules. Okay, so we have this next part here. It says the train accelerates for 180 seconds. The train has an input power of 16 megawatt. While accelerating, determine the work done against air resistance as the train accelerates. So it's very simple question. We need to just follow the strategy. And what is the strategy? First, identify what values we have been given. So we have time, which is 180 seconds, and we have power, input power, which is 16 mega. Mega is 10 raised to power 6. 10 raised to power 6 watt. Okay. Now, second step is to identify what they are asking us, right? Identify what they are asking us. They are asking us to find the work done against air resistance as the train is accelerating. How will I find that? Okay, so a train, in order to move, like at start, basically a train is given some power or even has some work done while it is accelerating, right? So if you can see from the statement, it was given this much of power, right? It was given 16 megawatt, right? While it's accelerating. So from this power, input power, this total power, some of that will be used against air resistance and some of them will be useful, which will be helping us to make that train go forward. Okay, two things. So you first, from this statement, we will get our total work done, right? And from that work done, some of them will be given to air resistance, AR, and some of them will be useful to us. So we have to identify this WT, and then you have WU, which is useful work done from the previous part, 2.1 times 10 to the power 9. And you can calculate WAR, right? So WAR is equals to WT minus WU. Now, which formula can we use to get the work done? So we can use power is equals to work done by T. So power is 16 times 10 to the power 6. Work done and time is 180 seconds. Now if you calculate this, and you will get your work done as 2.9 times 10 to the power 9, right? This is your total work done. And now you will use it here, which is work done against air resistance is equals to total work done, which is 2.9 times 10 to the power 9 minus the useful work done, which is 2.1 times 10 to the power 9. If you subtract it, you will get your value as 0.8 times 10 to the power 8 joules, right? Sorry, not 0 point, my bad. It's 8.0 times 10 to the power 8 joules. Sorry. So this much of work done is done against the air resistance. Yeah. So just write it here. And I hope that you understood this whole concept. Okay. Do it strategy by, strategic way, step by step, and you will get your answer very much faster. Okay.